So we know what the base function e to the x looks like. What does 1/2 e to the minus x minus 1 look like? E to the x has a domain of all reals and a range of y strictly greater than 0. It has a horizontal asymptote along the x-axis, aka y equals 0. What kind of transformations do we have? So a vertical compression of a half. Then x goes to minus x will reflect it in the y-axis, as in flip it backwards, and the minus 1 will move it 1 down. Okay, so we know that our horizontal asymptote is flipping 1 down, is moving 1 down. So our horizontal asymptote is going to be here. This reflection in the y-axis is going to take this function, this exponential growth, and turn it into exponential decay. That's e to the minus x in red. It's going to flip the orientation of that graph. And the vertical compression is just going to make all of my y values half the size. Can you remember how to write a mapping for this kind of a transformation? Any point xy on the original graph mapped over to negative x, because we reflect it across the y-axis. What happens to the y's? They're all 1/2 as big, and we move them 1 down. So we've got a key point on this graph right here. Put it through the mapping. What happened to the point x is 0, y is 1 under this kind of a transformation? Negative 0 is still 0. 1/2 of y, 1/2 of 1 is a half. Subtract 1, I've got negative a half. So x is 0, y is negative a half, and we're going to graph this. So it's going to look something like that. By the way, if I asked you to find the x-intercept, would you know how to do it?
Yes.
Do it then. Okay, you substituted 0 in for y, and now you want to isolate your exponential. So we're going to add 1 to both sides. Now what are we going to do? Are we? We're going to multiply both sides by 2. You're saying divide by 1/2, same as multiplying by 2. So I get 2 is equal to e to the minus x. In the next lesson we'll talk about this, but I'll just throw this in here quickly. You're trying to solve for a variable and an exponent. You all want to take the log of both sides, don't you? When the base is e, use ln, such as the ln of 2 is equal to the ln of e to the minus x, because the ln is just log to the base e, same number. Ln laws will work the same as exponent laws. We'll have ln 2 equals negative x times the ln of e. Why don't you grab your calculators and find out what the ln of e is? Somebody said it already. How do you know it's 1? Because the ln of e means log to the base e of e. How would you do it on here? Press your ln button and put e in there. What's the ln of e? It's 1. Right under log. Here's your log button, here's your ln button. How do you find e? Second divide. Okay, so ln 2 would give me negative x times 1. Ln of e is 1. Or negative ln 2 would give me x. Okay, what's the ln of 2? Ln 2. Negative 0.69. So check your graph. Is that about where we've got it? About there. So what's my x-intercept? About negative 0.69 when y is 0. Okay, for what values of x will e to the x be bigger than 1,000,000? As in, what power do I raise e to in order to get a number bigger than 1,000,000? How would I solve that? So e to the x bigger than 1,000,000. If that was 10 to the x, you'd know the answer to that, wouldn't you? What would it be? Yeah, 6. It'd have to be bigger than 6. What about if it's e to the x? How are you going to solve that? You're going to take the ln of both sides. Your power law brings that x down in front. What's the ln of e? 1. I need x to be bigger than the ln of 1, 2, 3, 4, 5, 6, 1,000,000. I need x to be bigger than 13.8. So I guess 14 would be, e to the power of 14 would be bigger than 1,000,000. E to the power of 15, as long as my exponent is bigger than 14. You guys did homework this weekend that you're going to show me later when I come around. I would like you to now do the questions that you omitted. So take a couple minutes and look those over.